Hello everyone. Today's topic of discussion is the basics of triangles. So in this video what we'll be doing is the very first thing that we'll be understanding is how do we define a triangle. So basically there are like four things which you need to know about any triangle. Second thing, once we're done with defining the triangles, then we'll be understanding how do we calculate the internal and external angles of a polygon. We'll be deriving the formula for both of them. Once we're done with that, then we'll understand how do we calculate diagonals of a polygon. So in this video, we'll simply be understanding the basics of triangles, nothing fancy. We will not even be understanding the different types of triangles. For that, I'll be preparing a separate video for a better understanding. Okay, so without much delay, let's get started. So the first thing is what we need to understand here is how do you define a triangle? So we all know that triangle is the smallest polygon. Now before we understand how do we define a triangle, let's understand this term polygon. So what is a polygon? Polygon is basically a closed figure made up of straight lines. Polygon is a closed figure made up of straight lines. Any closed figure which is made up of just these straight lines is known as a polygon. So triangle is the smallest one. After that you have a quadrilateral which is made up of 4 sides. After that you have a pentagon which is made up of 5 sides. Then you have a hexagon which is made up of 6 sides, and so on and so forth. So polygon is simply a closed figure which is made up of straight lines. Now when we talk about triangle in specific, triangle being the smallest polygon, you cannot have a polygon with less than 3 straight lines. You need at least 3 straight lines. Okay, so when we talk about defining a triangle, there are basically 4 things you need to remember, and these 4 things are true for any triangle that you'll ever come across, be it a equilateral triangle, be it a right angle triangle, be it a scalene triangle, be it an isosceles triangle, acute triangle, obtuse triangle. Whichever triangle you'll ever come across, these 4 things will remain constant. So first of all, it's a polygon with 3 sides. Second thing is sum of internal angles is equal to 180 degrees. Now these two everyone knows. Again, nothing new in these two properties. 2 more properties which you need to know, which are important, which will be required in order to solve the questions also. I'm using a different color for them so that you remember them. Third one is sum of any 2 sides in a triangle is always greater than the third side. Take example of any triangle. For example, you can take a right angle triangle into consideration. Let's suppose it has sides 6, 8 and 10. So you'll observe that 6 plus 8 is greater than 10, 8 plus 10 is greater than 6, and 6 plus 10 is greater than 8. For example, take another triangle. Let's suppose 3, 4, 5, another right angle triangle. So 3 plus 4 is greater than 5, 3 plus 5 is greater than 4, and so on. Okay, so in a triangle, sum of any 2 sides is always greater than the third side. This is always true for any triangle that you'll ever come across. And the fourth is the reciprocal of the third one, that is difference between any 2 sides in a triangle is less than the third side. So take example of again 6, 8 and 10 and 3, 4 and 5. 8 minus 6 is 2, which is less than 10. 10 minus 6 is 4, which is less than 8. And 10 minus 8 is 2, which is less than 6. Similarly, you can do it for 3, 4 and 5 also. So these two are important properties, so please remember them. So using this, for example, if I ask you a question, out of the following, which can form a triangle or which can be the sides for a triangle. And let's see if I give you 4 options. So which of the following options represent sides of a triangle? So in the first one, you'll observe that 6 plus 6 is 12. 12 is less than 13. However, it has to be the opposite way. If it has to be a sides of triangle, right? So A goes out, or option A goes out. 7 plus 8 is equal to 15. 7 plus 8 should be greater than 15, not equal to. Okay, remember that the sign is that of greater than or less than. There is no equal to in this. 2 goes out, same way 4 also goes out. 9 plus 7 is 16. 16 is greater than 15. Now, interestingly, what you need to also understand is if either of the 3 or 4 satisfies, then the another one will automatically satisfy. For example, if we look at option number 3, 9 plus 7 is 16. 16 is greater than 15. 9 plus 15 is 24, which is greater than 7. 7 plus 15 is 22, which is greater than 9. If you take the differences also, they will also satisfy. Okay. So anyways, this is how we basically define a triangle. All right. Now, moving on to the next thing, that is internal and external angles of a triangle. This is the first thing that we need to understand. Now, whenever you talk about a triangle, whatever type of a triangle it may be, a triangle consists of 3 internal angles and 3 external angles. A triangle consists of 3 internal angles and 3 external angles. So let's do one thing. Let's name the 3 internal angles as 1, 2 and 3. And let's name the 3 external angles as, let's call this 6. Let's call this 5. And let's call this 4. Now remember that whenever you talk about external angles of any polygon, you can measure the external angles of a polygon either in clockwise direction or in anti-clockwise direction, right? So what I have done in this case is, if you'll observe that for 5, 6 and 4, I have drawn these arrows, which basically represents the direction in which I am measuring the angles. So I'm measuring the angles 4, 5 and 6 in anti-clockwise direction. You could have done that in clockwise direction also. It's one and the same thing. Second thing which we need to remember here is that a pair of external and internal angle always lie on a straight line. A pair of external and internal angle of any polygon, doesn't have to be of triangle only, for any polygon, they always lie on a straight line. So from there I can say that 1 plus 4 should be equal to 180, because sum of the angles on a straight line is 180. Everyone knows that. 2 plus 5 is 180, and 3 plus 6 is also 180. So if I sum these 3 equations, I'll get that sum of internal plus external is equal to 3 into 180. Sum of internal plus external is equal to 3 into 180. Now, what I'm going to do is, first I'm going to calculate the external angles. We're going to decide, like we're going to evaluate how can we calculate some of the external angles of any polygon. Then we'll move on to the internal part. Okay. So in order to calculate the external angles, what I'm going to do is, I'm going to keep on compressing this triangle. Like I'm going to make this triangle smaller and smaller, keeping the proportions of the 3 sides same. So I'm going to make this smaller and smaller. So what's going to happen, this triangle will, there will be a point where this triangle will become so small that it can be represented using a dot. So this dot that you see, this is basically a triangle. Okay, we have basically compressed it. We have made it smaller and smaller and smaller. Another way of imagining this is that if you make a triangle on a grid, you keep on increasing the grid size. You keep on increasing it, increasing it, increasing it, increasing it, till the point that your triangle becomes a dot or a point. Okay, so what's going to happen is your external angles around this dot or around this point can be represented as something like this. So this is your angle 5, this is your angle 4, and this is your angle 3. Now we discussed this in circles that around a point or around a dot, sum of the angles is equal to 360 degrees. Okay, sum of the angles is equal to 360 degrees. So I can say that sum of external angles of a triangle is equal to 360 degrees. Now interestingly, this conclusion is true for any type of polygon that you may have. So what I've done is, for our better understanding, I've taken a quadrilateral here. So let's draw the external angles. So this is going to be 1, 2, 3, and this is going to be 4. So again, I'm taking them in anti-clockwise direction. If you want, you can take them in clockwise direction also. Now keep on reducing this, or like make this quadrilateral smaller and smaller. Again, up to an extent that it becomes a dot. Okay, so once you do that, you'll observe that you can represent your external angles around that dot as something like this. So this is your angle 2, this is your angle 3, this is your angle 4, and this is your angle 1. So again, you can say that your sum will be equal to 360 degrees. So basically, what we have generalized here is that, and this is an important conclusion which you need to remember, that sum of external angles of any polygon is equal to 360 degrees. Sum of external angles of any polygon is equal to 360 degrees. Remember this. Now we are able to generalize the formula for external angles. The same way I would like to do it for the internal angles also. Okay. Okay. Before we go into that, let's discuss one more thing, that is what is a regular polygon. So when you talk, you will come across two terms. One is regular polygon and one is irregular polygon. So regular polygon is basically a polygon whose all sides are equal and whose all angles are equal. Regular polygon is a polygon whose all sides are equal and all angles are equal. In case of irregular, not all sides are equal and not all angles are equal. So let's suppose, for example, if someone asks you, find the measurement of one of the external angles of a regular hexagon. Find the measurement of one of the external angles of a regular hexagon. Now, sum is 360. Sum of external angle of any polygon, be it regular or irregular, it's always 360. Now, when you talk about a regular hexagon means that all sides are equal and all angles are equal. Therefore, all external angles will be equal to one another. So, if you consider one angle to be theta, you can say that 6 theta will be equal to 360 and theta will be equal to 60 degrees. So in case of regular, Since the sum is constant, you know the number of sides, which means you know the number of angles. You can calculate one of the angles. If in case my question was simply find the measurement of one of the external angles of a hexagon, in that case your answer is cannot be determined. Since I'm using that word regular, therefore you are able to calculate it. Okay, because in case of regular, all angles are equal. So remember this, whenever you talk about regular polygon, all sides equal, all angles equal. So let me give you a couple of examples of regular hexagon, equilateral triangle, square. Okay, so these are the examples for regular polygon. All right, anyways, let's move on to the internal part now. So in order to evaluate the formula for internal angles of a polygon, what I'm going to do is I'm going to consider an n-sided polygon. Okay, so if I'm going to consider an n-sided polygon, so I'm going to have like n vertices, which means I'm going to have n pairs of internal and external angles. So I can say that sum of internal plus external will be equal to n into 180. Why n into 180? Because when I had 3 sides, my sum was 3 into 180. Now I have n sides, so my sum is n into 180. Now I know that sum for external is constant. So I'm going to write sum for internal plus 360 is equal to 180n. Or I can say that sum for internal will become 180n minus 360. So sum for internal is, you can take 180 common, and this will become n minus 2. So for n-sided polygon, sum of internal angle is n minus 2 into 180 degrees. So this is the formula which you need to remember. So first is this, and second is this. So for example, if I ask you like find out the sum of internal angles of a pentagon, so pentagon is 5 sides. So this will become 5 minus 2, 3 into 180, which is equal to 540 degrees. If I ask you for hexagon, replace n by 6. So 6 minus 2 is 4, 4 into 180 is 720 degrees. For triangle, replace n by 3. You're going to get like 3 minus 2, which is 1, 1 minus 180, 3 minus 2, which is 1, 1 into 180 is 180 degrees. For quadrilateral, replace n by 4, you'll get 360 degrees and so on and so forth. Okay. So remember these two formulas. And also remember that when you talk about a regular polygon, all sides are equal and all angles are equal. This is what you need to remember. Okay, one more thing that we need to do for this video, that is how do we calculate diagonals of a polygon. So what I've done here is that first we're gonna take an example and we're gonna understand how do we draw the diagonals. So diagonals are basically line segments formed by joining any two non-adjacent vertices. So what are diagonals? Diagonals are basically line segments which are formed by joining any two non-adjacent vertices. So you'll observe that in case of a triangle, there are no non-two adjacent vertices, so number of diagonals are 0. In case of a quadrilateral, you can have one diagonal something like this, and you can have another diagonal something like this. In case of hexagon, you can have like many diagonals. So I'll draw like a couple of them. Now this, then I can have this. Now let me change the color. I can also have this. I can also have this, and likewise you can draw it for other vertices also. So the point is, how can we calculate? So let's try and understand. So let's consider a polygon having n sides. I have a polygon having n sides. Okay. Now if I select any of the sides, since I have n sides, and if I select only one side in order to draw the diagonal, or side is not the right word, if I have polygon with n sides, I'm gonna have like n vertices. Okay. In order to draw a diagonal, I'm gonna select one vertex first of all. So in how many ways can I select one vertex out of n vertices? I can select it in n ways. For example, if you see the quadrilateral above, you basically have four vertices. You can select this one, you can select this one, you can select this one, you can select this one to draw a diagonal, right? You can select any of them. So if I have like n sides, I'm gonna have n vertices. That means I can select one vertex in n ways. There are n ways of selecting one vertex. Now in order to draw a diagonal, I cannot use the vertex that I have already selected. Apart from that, I cannot also select the vertices which are adjacent to the selected vertex. So what I mean by that, let's say suppose you have selected this vertex A. Okay, let's call them A, B and C, D. So you have selected this A. Now if you have selected A, you can't select A again. You can't select B and you can't select D, because B and D are adjacent to A, and A is you have already selected, so you can't select it again. So the first thing was I was able to select one vertex in n ways. If I want to select the second vertex, it has to be in n minus 3 ways. Why n minus 3? Because you will be subtracting the vertex which you have already selected. You will also be subtracting the two vertices which are adjacent to the selected vertex. So you can select the first vertex in n ways, you can select the second vertex in n minus 3 ways. Now another thing which you need to understand is, when you talk about the diagonal, whether you count that as AC, I mean whether you call this diagonal as AC or whether you call this as CA, it's going to be one and the same thing. So this n into n minus 3 will be divided by 2, because as of now you're starting with A, so you have one diagonal that is AC. When you'll go to C, you can again say that you have a diagonal CA, but AC and CA are one and the same thing. The naming, remember that the naming in geometry is for our own convenience, it's not for the figure's convenience. So whether you call that as diagonal AC or whether you call that as diagonal CA, it's one and the same thing. So that's why I'm going to divide this by 2. So how do you calculate number of diagonals? It's n into n minus 3 divided by 2 ways. So for triangle it will become 0, because as soon as you replace n by 3 it will become 3 into 0 by 2. For quadrilateral it will be 4 into 1 by 2, that is 2. So you can see that I have two diagonals. For hexagon it will be 6 into 3 by 2, which is 9. So when you'll complete like all the diagonals, you'll observe that you're gonna get like 9 diagonals. Okay, so this is how you can calculate the number of diagonals for a polygon. So we understood a couple of things. Let me just revise them for you. First thing what we understood was what is a triangle. So we defined triangles using 4 basic properties. That it's a polygon with 3 sides. Sum of the internal angle is 180. Sum of any two sides is greater than the third one, and difference between any two sides is less than the third one. Then we moved on to internal and external angles of a triangle. So as of now, just remember the formula. The proof is not required, because our exam is more based on the application of these formulas and not on the proof of these formulas, right? So for internal angle, the sum is n minus 2 into 180, where n is the number of sides or number of vertices, and external angle is 360, irrespective of whatever type of polygon you may have, be it regular, be it irregular, be it a triangle, square, whatever you may have. The sum is 360. Then the last thing that we discussed was the diagonals of polygon. The formula is n into n minus 3 divided by 2. Okay. So this is what you need to remember as far as this video is concerned. In the next video, we'll be understanding the types of triangles, and then we'll move on further. So thank you guys so much for watching this video. Keep watching and keep learning. Thank you so much.